So we're going to go through all of the key parts of graph A, and then y'all are going to do graph B. So for graph A, we have to start with looking at what is the axis of symmetry for graph A. That's question 1. So if I'm looking at this graph, where is the axis of symmetry? At what x value does the axis of symmetry run through? What divides this graph in half? -2. So through that vertical line at -2 is our axis of symmetry. Okay? So in order to write the axis of symmetry, we always start with x equals then whatever the value is, because we're writing the equation of that line. And that is x equals -2. All right, now, for question 3, it asks us, what is the vertex of graph A? What would the vertex of that graph be? What is the vertex of that graph? -2. Is it -6 or is it -5? 1, 2, 3, 4, 5. -2, -5 is our vertex. Okay? And obviously you'll be writing this in on the blank. So -2, -5. Is that a maximum or a minimum? Minimum. If it makes a valley and it's at the bottom, if it's the lowest point, it is a minimum. All right. Now we have to identify the domain and the range. Obviously, you're going to write your answer on question 5. But just so we can look at the graph, I'm going to write everything up here. So domain is our x values from left to right. So does this graph ever stop going left? No. Does it ever stop going right? No. So what would our domain be? -infinity to positive infinity. And we always use parentheses for infinity. Okay, our range. Range looks at our y values from bottom to top. So does this graph ever stop going down? Yes. Where is the lowest y value on that graph? -5. Now, does this graph ever stop going up? No. So where does that go? Infinity. So infinities get parentheses, okay? But the only other thing that gets a parentheses is an open circle. But this right here is a point, so we would put a what? Bracket. So we go bracket, then parentheses there. Okay, so that's what you should have for number 5. Your domain is -infinity to positive infinity, and your range includes -5, and it goes to infinity. All right. Now, the last question it asks us is to identify the equation for graph A. So we have 4 choices, and we can use process of elimination. So first, does this graph for graph A open up or open down? Opens up. So that tells us our A value is positive or negative? Positive. So if we look at our choices, knowing that our A has to be positive, what does that automatically cancel out? C and D. So it can't be C and it can't be D because our A value has to be positive. Now we have 2 options left. So I'm just going to start with option A, and I'm going to calculate the axis of symmetry and just see if that one works, because we're just using the process of elimination here. So when we look at A, what is our A term on option A? 1. What is our B term?
-1.
What is our C term? -1. So we're going to use that and find our axis of symmetry. So we're going to do x is equal to -b over 2a. What do I need to plug into the numerator? A, B, or C?
B.
B. So we need to plug in,
-4 and then A.
which would be what in the denominator?
1.
1. So when we do that, What does our numerator become?
A positive.
Positive 4 divided by what is 2 times 1?
2.
What is 4 divided by 2?
2.
2. So is our axis of symmetry for graph A x equals 2?
No.
So can it be A? No. So what does that leave for our answer? B. Right? So what I want y'all to do is I want y'all to take a few minutes and I want you to do all of the questions for graph B. It's the exact same, just go over it for graph B.
So do I just circle it?
For question 6 or 7 or question 7,
7.
you just circle the B, yeah. Question 8, you have to do the same thing. But you're doing it for graph B.
Grab the yellow ball basket.
How do you tell the difference between maximum and minimum?
So if it as the highest point, it's a maximum. If it's the lowest point, it's a minimum. All right. So if we look at graph B, okay, what is our axis of symmetry for graph B? 3. Okay. What is our vertex? 3, 4. Now, this is a maximum because our graph, it makes a little mountain. So it has a highest point. Okay, it has a top of the graph. Okay. Our domain is negative infinity to positive infinity. But our range here, okay, I want us to talk about the range. So does this graph ever stop going down? No. So where does that mean it goes? Negative infinity. Does this graph ever stop going up?
Yes.
What is the highest y value that graph goes to? 4. So it's going to go from negative infinity to 4. Negative infinity gets a parentheses, and 4 gets a bracket. Because it's not an open circle, so it gets a bracket. Okay? And that should be what we do for that. Now, does this graph open up or down? Down. So that means our a term needs to be negative. Okay? So that automatically counts out options A and B. Right? So what is the correct answer for the equation for number 8? D. Okay? Which we can find that by checking the axis of symmetry. If we look at C, the axis of symmetry is -3. Whereas if we look at the question D, the axis of symmetry is +3, which is correct. All right. So that is what we should have done for this part here. Okay, now, today we're going to look at more than just the key parts. Yesterday we pretty much just talked about the key parts of everything and finding those things. Today we're actually going to look at not just sketching the graph, but graphing the most exact points that we can. So what we're going to do is we're going to go back to our white packet, and we're going to go to the second page of it. And it is the 8.1 graphing in standard form. So we do all need a graphing calculator. If you don't have one, grab one. All right. So we're going to start with the steps to graph a quadratic equation. Okay, most of these are steps we've already been doing for like today or yesterday and today. Okay, so we're going to start with finding the axis of symmetry. So we use the formula to find our axis of symmetry. Okay, we do that because it kind of gives us the location of where we're looking for everything else. Okay, so to find our axis of symmetry, we do x is equal to -b over 2a. And that is the formula we're going to use for that every time. Okay, step 2 is we have to find the actual vertex. So in order for us to find the vertex, okay, we have to find the point. So the x coordinate of the vertex is always what x value we just found in our axis of symmetry. So it will be -b over 2a. It's whatever we just found. How do I find the y value if I'm given the x value? What do I need to do with that x value? Plug it in. We're going to plug in x to find y. We use the same x value that we find in the first step and the second step. We just plug it in. Okay, now, we have to put our vertex in the middle row of the table, because we're going to use a table to list all of our points. Then we're going to fill in the table of values using a calculator, okay? So if I want to insert an equation into my calculator so that it can graph it, what button do I press?
Y equals
So we're going to first do y equals and type in your equation.
X.
Okay, so y equals and whatever your equation is, okay? Then, to look at the table on here, not graph, but to look at the table, what buttons do I click? It's the same ones we did in Unit 6. What buttons do I click to look at the table? Second, graph. Okay, so we start with y equals, put in our equation. Then we do second graph, and that will give you the table of values for that equation. Then we just plot the points and connect them into a smooth parabola, okay? That smooth parabola part is important, okay? We have to make sure our graph is actually a U shape, okay? When we put these points together, they're going to almost be in the shape of a V. You have to make sure you curve out the line because it is a curve. If you do straight lines, you're graphing something entirely different. So I want you to make sure you make it a curve, okay? It should be a U shape. not a V shape. All right, so we're going to go through these 3 equations, and then we're going to practice a little bit more, okay? So we're going to start with number 1. When we start one of these problems, the first thing we're going to do is always find our A, B, and C, okay? So what is our A term here? What's understood to be in front of x squared? 1. So our A is 1. What is our B term for this one? 0, because there's nothing there. Nothing is just 0. What's our C term? 0. Now, is this graph going to open up or open down? Open up. We know that because our A is positive, right? The reason I want you to include the opens up or opens down is because I always give kind of like a freebie question on these. And you have to circle whether or not the graph opens up or opens down, right? So you need to be able to make sure you know if it opens up or down. Now, we're going to go to axis of symmetry, okay? So we're going to figure out what x is equal to if we have negative b over 2a. What do I need to plug into the numerator there? 0. We plug in our b. What do I need to plug into the denominator? 1. What is our numerator going to give us? 0. What's our denominator going to give us? What is 0 divided by any number? 0. So our axis of symmetry is just x equals 0. Then that is also the x coordinate of our vertex. So now we have to find our y coordinate. So to do that, okay, that is where we take and we plug in x to find y. So we're going to look at our original equation right here. So we're going to do y is equal to x squared. But what do I need to plug in for x? 0. What is 0 squared? 0. So our y coordinate here is 0.
Miss Williams?
Yes, ma'am.
When you're done teaching, I gotta tell you the T.
Okay. All right, now, when we look at this, okay, our vertex, it has to go in the middle of our table because our vertex is the middle of our parabola, okay? So it goes in the middle. And then we're going to put points on both sides of it. What is a number that's smaller than 0? -1. What's even smaller than that? What's bigger than 0? 1 and 2. Okay, so what we're going to do is we're going to use our graphing calculator. We're going to go in, we're going to click y equals, clear it out if there's something there, and we're going to type in x squared. Once you have it in, we do second graph, and it gives us our table of values. You can scroll through that, okay, to find what you need. Using that table in your calculator, when x is -2, what is y? 4. When x is -1, what is y? When x is 1, what is y? When x is 2, what is y? Parabolas are symmetric. Those 2 points should be the same, and those 2 should be the same every single time, okay? So now we're going to go ahead and graph everything. So over here, we're going to plot our axis of symmetry using a dashed line. And we're going to plot all of our points. So we're going to do -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And then draw in your parabola. That wasn't good. Good gracious. Why is it not auto-correcting to a nice, pretty parabola? There it goes. And that is what our graph should look like. Okay? That has everything on it we need. Now we're going to use that to do our domain and range. What is our domain of that graph? Does it ever stop going to the left? So that means it goes to -infinity. Does it ever stop going to the right? Also no, so that means it's going to +infinity. So our domain is from -infinity to +infinity. Does this graph stop going down? Yes. Where is the lowest it goes? 0. Does this graph ever stop going up? So what's the highest it goes? And then for 0, I put a bracket, and for infinity, I do a parentheses. All right, now we're going to go ahead and we're going to look at question 2. Okay, for question 2, let's start with our A term, B term, and C term. What is our A term? 1. What is our B term? What is our C term? -1. So, from here, okay, does it open up or down? It's going to open up. Why does it open up? A is positive. Yep. Now we're going to find our axis of symmetry. So x is equal to -b over 2a. What do I need to plug into the numerator? What do I need to plug in? 2. What do I need to plug into the denominator? What is our A term? 1. So what does our numerator give us? If we have a negative and a 2, that gives us -2. What's our denominator? What's 2 times 1? What is -2 divided by +2? -1. So our axis of symmetry is x is equal to -1, and that is also the x coordinate of our vertex. Okay, now we're going to go ahead and plug that in. So we're going to plug in x to find y. So we're going to do y is equal to x squared plus 2x minus 1. So what do I need to plug in for x? -1. All right, what is -1 squared? What is -1 times -1? 1. Okay, what is 2 times -1? -2. Then we have -1. What is 1 minus 2? -1. What is -1 minus 1? So our point is -1, -2. And that is what goes in the middle of our table. Okay. If you are going to type this into your calculator to get the correct answer, you have to put it in parentheses. Okay. I'm going to keep saying that repeatedly because in Unit 8 and in Unit 9, the 2 mistakes that happen the most often are inputting it incorrectly into the calculator and getting the wrong answer, or forgetting a negative sign. Okay, those are the 2 most common mistakes. And they're honestly kind of silly mistakes because on your paper you can have everything right, but because the way you typed it into the calculator, it'll make it wrong. Okay, so I want us to avoid those. So be very, very careful with how you set up and plug in numbers. What is a number that's smaller than -1? -2. What about smaller than -2? What is a number bigger than -1? 0. Then we need to put 1. So I want you to use your graphing calculator and fill in that table for me. So go to y equals. Clear it out if there's something there. Type in x squared plus 2x minus 1. And find your table and fill it in. And remember, your points need to be symmetric. And once you have your points, go ahead and graph it. Your table and graph should look like this. And when we look at that, what is our domain? Does it ever stop going to the left? So that means it goes to negative infinity. Does it ever stop going to the right? So that is positive infinity. Does this graph ever stop going down? Where? What's the lowest y value? -2. Okay, that would get a bracket. Does this graph ever stop going up? So it gets a positive infinity with a parentheses. Okay, would that be a minimum or a maximum? Minimum. Okay, that vertex right there is a minimum.
Do we have to look at
If it asks. I just want to, as we're going through it, I'm going to randomly ask just so we make sure we remember. All right, question 3. So for question 3, we're again going to start with our A, B, and C term. What is our A term? -1. What is our B term? -8. What is our C term? -17. Is this going to open up or down? It's going to open down because our A is negative. Okay, now we're going to look at our axis of symmetry. So we're going to do x is equal to -b over 2a. What do I need to plug into the numerator right there? What is our b? -8. What do I plug into the denominator? -1. So what is our numerator going to be? A negative and a negative make a positive. So we get +8 divided by, what is 2 times -1? And what is 8 divided by -2? -4. Our axis of symmetry is x is equal to -4. That is also the x coordinate of our vertex. So go ahead and put that in there. Now we are going to find the y coordinate. So we're going to take and plug in to that original equation. Y is equal to -x squared minus 8x minus 17. I put everything that is in that equation here. I just replace x with parentheses. Then what do I plug in? What x value? -4. Okay, so when we look at this, what is -4 squared? What is -4 times -4? +16, but there's a negative in front, so that makes it -16. Okay, what is -8 times -4? +32. Then we have -17. What is -16 plus 32? 16. What is 16 minus 17? -1. So our point is -4, -1, and we put that right in the middle of our table. And then we fill in everything around it. So what is a number less than -4? Less than that? Okay, what about more than -4? Then, there we go. So I want y'all to use your graphing calculator, fill in that table and graph. So do your y equals, enter your equation, and then second graph. thank you. It was just a little squeaky, so I was worried. All right, your table should be filled in like this, and that should be your graph. And does this graph ever stop going to the left? No, so it is negative infinity. Does it ever stop going to the right? So its domain is negative infinity to positive infinity. Does this graph ever stop going down?
No.
No. So that means it's going to go to negative infinity. Does this graph ever stop going up?
Yes.
What's the highest this graph gets to? Negative 1. So it'll be from negative infinity to negative 1. All right. What I want us to do for the last about 15-ish minutes of class, okay, is we're going to go ahead and look back at our pink paper. And we're going to be on the 3rd page of the pink paper, graphing those 4 questions. So this should be the paper you're on, okay, and you're going to graph those 4 equations.